Okay, let's go on in lesson 6-1, solving systems by graphing. It says a system of equations. It says a system of equations that has at least one solution is consistent. A consistent system can either be independent or dependent. A consistent system that is independent has exactly one solution. For example, the systems in problem 1 and 2 are consistent and independent. A consistent system that is dependent has infinitely many solutions. A system of equations that has no solution is inconsistent. So let's take a look at problem number 3. It says, what's the solution of each system? Use a graph. So first, if I'm going to use a graph, I need to first put this in y-intercept form. So I have 2y minus x equals 2. So the first thing I'm going to do is add x to both sides. And I get 2y equal x plus 2. Then I'm going to divide both sides by 2. And I'm going to get y is equal to x over 2 plus 1. Or another way of saying this is 1/2 x plus 1. And I did that because that's the same as the second equation. So they're the exact same line. So if they're the exact same line, they don't even have to graph that to see. But if we didn't want to graph it, we can go to my free graphing calculator at www.decimals.com. And of course, it's going to take a long time to load. Let me pause. Oh, there it is. Alright, so we have y equals 1/2 x plus 1. So there I have it. Let's just, for the heck of it, graph it again. No, let's not graph it like that. Let's graph it the original 2y minus x equals 2. So 2y minus x equals 2. Exact same line, as you can see. So that means there are infinitely many solutions. So that means that this is a consistent dependent system. Okay, let's take a look at guided number 3. It says, well, what is the solution of each system in parts A and B? Use a graph, describe the numbers of solutions. So first one I have y equals negative x minus 3. And the second one is negative x plus 5. Alright, they're parallel. So that means that they never cross. And I know they're parallel because I can also look at my slopes. They're the exact same slope. So because they're parallel, they are inconsistent. And I'm sorry, I actually missed one of the problems here. This one was also parallel. I have 2x plus 2 and 2x minus 1. 2 and 2 are the same slope, so they're also, as you can see, parallel. So they never cross, so that means it's inconsistent. Let's look at part B. So there's no solutions for this one. So I have 3x minus 3. And I have 3y equals 9x. And I know I should solve it. We will solve it. We'll go back and solve it. Minus 9. But since I have this, oh look, it's the exact same line. I'm sure you probably felt the same way, that it was going to be the same line. They've given us an example of what they've already showed us to do. But if I solve it for y, which I should do, to put it in y-intercept form, I divide both sides by 3, and I get y equals 3x minus 3. This is the exact same thing as the first one. So that means there are infinitely many solutions. And so it's consistent, independent. C. Before graphing the equations, how can you determine, I'm sorry. How can you determine whether a system of equations has exactly one solution, infinitely many solutions, or no solutions? So we know that it has no solutions if they are parallel. Remember, parallel means the exact same slope. So if the slopes are equal, there are no solution. Infinitely many solutions is if they're the same line. And one solution would be a solution that was not like the other two that I just described. So I hope that this helps.